All right, we are on. Let me try and see if I can get a better view of like the whiteboard. We're using the whiteboard a lot today. So maybe you don't need to see me. All right. Maybe that's good, and I can just scoot in a little bit. Cool. Hey, if you're on, go ahead and say hi to me so I know who's there. We'll get rolling in about 2 minutes, but I just wanted to make sure we had everything set up. And if you're on, and I'd love to know, can you see everything okay? Or if I need to move, I guess I've got like a glare right there, but I don't know if that makes a difference. So I'd love to hear what you have to say. Cool, cool, cool. Hey, and before we get started, too, I'd like to thank people who have been asking questions, maybe giving suggestions on what to talk about today. I love that some of us have been trying that GeoGebra activity and maybe coming up with different conjectures and testing their conjectures to see if it's correct, or even sending some in and maybe submitting their assignment and asking if how things are doing. So that's great. Hey, I'm still waiting for people to say hi to me. I'm hoping I was chatting. I hope the chat is on. Hmm. If the chat isn't on, could I don't know. I don't know what to do if the chat's not on. To be honest with you. Um, okay. So from my standpoint, it appears as though the chat is on. So hopefully, people are just shy right now and don't want to say hi. If that is the case, that for some reason it's not on, I apologize. I'll try to just keep doing everything. Got my phone here, so if you sent like a Google Classroom message or something like that, I'd see it that way. But we'll get rolling. Um, Today, I know Mrs. Wenmaker yesterday kind of talked about the angle relationships in circles that has to do with your GeoGebra activity. I'm going to talk about those segments in circles, and hopefully, maybe the videos that were posted with the announcement this morning would help as well. Um, for the segments in circles, there are four kinds that we're going to focus on: the tangent, which we've talked about before this week, the secant segment, the secant tangent segment, and the chord segment. So we'll get rolling. And the tangent segment means we start with a circle, have some exterior point, and remember, a tangent line goes through that exterior point and only touches the circle at one segment, meaning from every exterior point of the circle, there is exactly two tangent lines that can be drawn. Exactly two tangent lines that can be drawn. Once we just go from that exterior point to the point of tangency, that these tangent lines now become tangent segments. Okay. And we've talked about this before, but yeah, those tangent segments are congruent. So two tangent segments from a common exterior point are congruent, or two tangent segments from a common exterior point have the same length. Okay, have the same length. This chat thing is bothering me. All right. Well, hi everybody. I apologize if the chat isn't working. I hope we'll figure this whole e-learning thing out one of these days. Okay. Um, so there we go. Tangent segments. That was the first one that was on our GeoGebra activity. Okay. The next one we talked about was a secant segment. So we still start with our circle and some common exterior point. This common exterior point would be where both of those secants emanate from. Okay. Mrs. Wenmaker told me the chat is working, which is great, but I can't see it for some reason. So I tell you what, Wenmaker, if you're trying something. Oh, there we go. Hey, I got it in a new window. Oh, crud. Hold on a second. All right. I see it now, everybody. Oh, thank you. Oh, everybody is saying hi, and Dixon saying it looks good, and I'm not seeing any of that. Fantastic. Oh, good morning, good morning, good morning. Um, Henry Hirsch, hello, hello, hello. All right, fantastic. Oh, good. I'm glad I got this, guys. Okay, so back to what we're doing now. We've got ourselves a circle with this exterior point. And if we draw two secant segments, we could draw a secant line and it would just continue on through all these things. The generalization that we did on the Google, or I'm sorry, on the GeoGebra activity had this length like being W, this length being X, this length being Y, and this length being Z. All right. And I peeked and I saw some people that did a great job of playing around and playing around and playing around with it. But ultimately, we have products of lengths that are equal to one another. So starting from this common exterior point, the length to the circle times the entire length of the secant segment would equal the length to the circle times the entire length of the secant segment. Or in other words, W times W plus X is equal to Y times Y plus Z. Okay, so the length outside times the whole length is equal to the length outside times the whole length. And that is what we end up with. Good morning, Benjamin. Hello, everybody. I can see chat now. This is fantastic. This made my day. Okay, so a length outside times the whole length is equal to a length outside times the whole length. So let's do a quick example here. If we had some lengths, like maybe this length was 5 and 7, and then this guy on the bottom, we had 6, and we didn't know this little bit in here. Okay, well, if we wanted to find out that little bit in there, we know that from that formula we just talked about, the amount on the outside times the whole thing. Well, the whole thing is 5 plus 7, right? The whole thing is 5 plus 7, so 5 times 12 would have to equal 6 times the whole thing, right? Times the whole thing. So some people at this point would just put some variable in there, like an X or something like that. Some might say the 6 plus the question mark. Either way is fine, however we want to think about it. This isn't too much algebra going on. Hi, Molly, good morning. So we have 60 now is equal to 6 times this 6 plus question mark. And we can get through this algebra quite easily. Yeah, divide by 6. And yeah, I think I see Sophia threw it in there. 4 ends up being the length of that question mark. Oh, lots of people threw it in there. Fantastic. Hey, remember your tickets. I have to figure out a way to do social distance high five tomorrow for High Five Friday. I miss high fiving everybody on Friday. Okay, so there's our secant segments. Okay, great. So we have that formula from before, and then it's just plugging those things into the formula. And the purpose of the GeoGebra activity was to hopefully get students to discover things on their own, because there's a benefit in mathematics to playing around with it and trying to figure it out on your own. All right, so the next one now we have is a secant tangent relationship. Okay, a secant tangent relationship. So if we have a circle, and then we'll go ahead and just draw that tangent segment in there. But then emanating from that same exterior point, we have a secant segment. So all of a sudden now we have two segments, one of which is tangent to the circle, and another of which is a secant segment. So remember, yesterday, Mrs. Wenmaker talked about the measure of this angle being half the difference of those two intercepted arcs, where the intercepted arc is like on the inside, the interior of the angle. So in this case, I think our GeoGebra activity had these linked as W, Y, and Z. W, Y, and Z. I don't know what you mean, Ryan, by elbows. Oh, instead of high five, yes, boom. We'll give some virtual elbows to each other on High Five Friday. Cool. So in this case, I peeked at some GeoGebra activities and I saw some people play around with it, and I saw some people that actually got it, which was great. It was W squared. So this length that can go to the circle, this tangent length, would equal the same as those secant segments, right? Y times that whole length of Y plus Z. Okay. Now, if we think about this, I want this to make sense to you instead of just memorizing a formula. We had to square W because we had to get units the same on each side, right? If we thought of these lengths as inches, we could never have inches equal inches times inches, inches equal inches squared. That doesn't make any sense. So we need two components of those inches. We need inches times inches, and that's why we have W squared, inches squared, would equal some number of inches times some number of inches to get inches squared. We need to maintain that equality of units on both sides of that equation. Okay. So I see chat. If there's things that come up, go ahead, type them in, and I will see them. But I want to look at an example with this one. So let's go ahead, have the same diagram, and let's put a secant, tangent, some lengths in there, or maybe that length up there of the tangent segment is 10. And if we have this length being 5, but we want to find the length of the chord that's inside the circle. Okay, just the length of the chord that is inside the circle. Well, I'm slowly getting the markers over here, right? So I give you time to think about it. That's a teaching strategy. Teaching 102 is what that is. So in this case, we know we have to square the tangent segment. And that would be equal to the length of the secant that is outside the circle times the entire length of the secant. Now, the last time we went in here, we did 5 plus question mark. Some people we mentioned would just put like an X in there and then figure out what question mark is later. Either one is fine. We'll go ahead and go 5 plus question mark again. The algebra here isn't so bad, right? 10 squared, boom, 100. Not even going to wait for it. Oh, people are throwing answers in already. Nice. So we have 5 times this 5 plus question mark. Certainly we could divide both sides by 5. And yeah, all these people that are throwing 15 in the comments, ticket, 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 ticket. You all get tickets. Remind me when we get back to school. All right. So certainly when we subtract 5, we end up with 15 being that length. Okay. So quick question for people who are throwing some comments in there. How come when we had a tangent segment, we didn't need to do tangent segment squared times tangent equals tangent segment squared? Here we had to square that tangent segment. How come we didn't have to in the earlier one? I'm going to erase and wait for your comments. So why didn't we need to square those tangent segments if we're squaring the tangent segment in a secant tangent? Yeah, Dixon, I know where you're coming from on that. But if we had like some tangent segment squared was equal to some tangent segment squared, couldn't we just kind of like take the square root of both sides, right? And really, we understand the absolute value, but we're talking about positives. So we didn't need to square them both. True that those two tangent segments would be equal. Those two tangent segments would be equal. So their squares would have to be equal also. Just didn't need it. Just didn't need it. All right, cool. Hey, we got one more, guys. One more. And this is awesome. See a lot of people that are on here. So thank you for coming on there. Hi, Hayden. Hello. And all these people that are saying make the units equal. Yeah, totally. Because our units were equal and it was just like inches and inches. Didn't need to square them to get inches squared and inches squared. So our last relationship dealt with two chords. So like if we had two chords intersecting, and on our GeoGebra activity, oops, W and I think this was X, pardon me. And then we had Y and Z. And so in this case, very similar to the segment, or I'm sorry, the secant, is that these products now are going to have to be equal to one another. So if we were to make a formula out of this, some people I noticed on their GeoGebra activity just kind of like typed out what was going on in words. Cool, you get it. And maybe go back and revise that so we have a formula on there also. These segments that are created when these two chords intersect, their products would be equal to one another. So in this case, Wx would be equal to Yz. So W times X would be equal to Y times Z. Now, I'm going to back up real quick. Remember, Mrs. Wenmaker talked about the chord angle being half the sum of the two intercepted arcs. Maybe remember that as we're doing this, but today's lesson is more about the segment lengths. So let's do the same thing that we did on the previous ones. We'll throw some lengths in here and make sure we know how to go ahead and figure those out. Let's see. Ooh, is this a fun marker? Does this work? What if we called this length up here 4? Maybe you can't see that well. Hold on. Maybe we call this length 4, and this length 3, and this length 2, but we don't know this guy over here. I need a favorite variable. How about a smiley face? So that formula that we just talked about, well, people are throwing in answers before I can even do this. Here we go. Hold on. So those products have to be equal to each other, right? So 4 times 3 has got to equal 2 times smiley face. Oh yeah, I see a lot of people saying 6. Ticket. Cool. So yeah, in this case, 12 is equal to that 2 times whatever that variable is. So 6 was the length we were looking for. Okay, 6 was the length we were looking for. So we went over the tangent segments where they're congruent, the secant segments where we have a product on each side of the equal sign. We went over the secant tangent segments where the tangent squared would be equal to the product of those two lengths on the secant. And then went over the chord where those products would be equal as well. Okay. Keep going with that GeoGebra activity. Make sure you're filling out the places where you make a conjecture and go ahead and turn it in. We will be looking at that. And then for tomorrow, there's a 12-4 Pearson activity that hopefully after you do the GeoGebra and after you watch these videos, you've got that stuff down. Keep in mind also that people who have completed all the Pearson stuff will get a benefit in the gradebook when we get back to school. So you might want to double check to make sure you've completed all the modules from 12.1 through 12.4 and the homework check and everything else that's on Pearson during this e-learning time. Miss you all. Hope things are well. And if anything comes up, go ahead and reach out via Google Classroom or email or anything else like that. I hope to see you guys soon, and before you know it, we'll be back giving high fives on Friday like that. All right, bye everybody.